beautiful. Okay, so I hope everybody is doing really, really well. And I had so many people say to me, Mr. Kramer, we want to go back into outer space. We want, oh, thank you, Will. You were able to do that. Awesome. So we want to go back into outer space like we did last week to 10 to the 24th power. I'm not going to take you quite that far today. Today, I think I'm only going to take you to about 10 to the 12th power, maybe 10 to the 11th power. But the other students said to me, Mr. Kramer, we want to go into the atomic level also. We loved going into the cells to 10 to the negative 16th power to see the atoms. So would you guys like to go big and small today? And so what we're going to do is this. We're going to start with everybody. I assume everybody can see. Give me a thumbs up if you can all see our solar system. Can you guys see our solar system? Yes, you can see the solar system. That's great. And guess what? This is usually the picture that you get to see every time you see a picture of the solar system. Now, I have to show you something. I was a busy bee, and yesterday I created my own model of the solar system. So I want you guys to check out my model. Isn't that a cool model? Here's the sun, okay? And here is, let's see, which one? It's kind of hard to tell because they're so much alike in size. Now this large one right here, this is Jupiter, and we know that this is Saturn because it's got the rings. But you know, these other ones are kind of the same size. I'm not really sure what to do with it. So I found out that when companies make toys and they print pictures like the one you're looking at, guess what? They don't pay attention to the real world. They do not pay attention to really how big or how small are the planets relative to each other. So I want you guys to take the sheet that you have, which is page 1, and put it to your left or right so it's not in front of your workspace. And what we're going to do, and I also got myself a ruler, and this is a centimeter ruler. Now, for some of you who don't have a ruler or a centimeter ruler, I provided one for you at the very bottom of that piece of paper. So you could actually use that to do your measurements. Now, the other thing that you're going to need is you're going to need a knife, a very, very plastic, safe knife. Now, I have a couple of questions, but I want to make a couple of more comments before I take those questions. And the comments are this. Some of you may not have been able to find Play-Doh. Some of you may not have been able to find Model Magic, or some of you may have not been able to find clay, and that's okay. This is only something that would be great to do during class. This happens to be my Play-Doh. If you have Play-Doh or Model Magic, hold it up to show me right now. I'd like to see what you have. Now, if it's in the jar, you should probably take it out of the jar and put all the pieces that you have together and start to make a big ball, or as mathematicians would say, a sphere out of those. Now, I'm going to take 2 questions here. I want Cam, you have your hand up. Go for it.
I cannot see your screen.
You cannot see my screen. Okay, well, I will share screen again. And I think what I'm gonna do this time is I'm gonna share the, and that happens to you a lot, Cam. So you have to make sure that you have the right buttons pushed on your computer so you can see.
I'm not on a computer, I'm on a tablet.
Yeah, so you have to work hard to make sure that happens. Xander, you also had your hand raised, buddy. Go for it.
So, I figured a solution for the 2's to make 8. 2 times 2. 2 times 2 plus 2 times 2.
Wow. And what is 2 times 2 plus 2 times 2, buddy?
4 plus 4.
Which is equal to?
8.
Oh my God, that is amazing. And you know, that's a really, really good solution. I think I'm gonna do something special here. I think that I am going to maybe make a mathlete dollar out of this young man. So I'm not sure that I can do it, but we will see if I am able to do that. So I may give that a try. Also, Victoria, can you raise your hand electronically? But you can talk to me now. Go for it.
So are we supposed to put all the Play-Doh that we have together?
Yes, you are. You're supposed to put all the Play-Doh that you have together. So start putting it together, right?
I have different colors and I really don't like them to get mixed.
And then you will have to use only one color. But for me, I do not mind mixing my colors. So I am going to continue to make this Play-Doh work for me. Now,
I can probably use just different colors to make different.
Yeah, no, you really can't. So you're going to have to put as many of them together as possible. It'll be a better experience for you today if you do that. Now, we are going to get started right now. And here's what we're going to do. Are you ready? Mr. Kramer is going to show you how to make a scale model of the solar system. This is our solar system.
It is.
And what I'm going to do is I'm going to show you how to split this up. Right now, this piece of Play-Doh that you're holding represents all the 9 planets in our solar system. It does not include the sun. This only includes, oh, Cam, that's beautiful. It only includes the 9 planets. So everybody now start to make a cylinder out of their Play-Doh. Now, a cylinder looks like this. It's got 2 circular bases, one on either side. And you guys have seen a cylinder before. So many different things come in cylinders. For instance, this tape is a cylinder. This pen is a cylinder. Most of the cups that we drink out of are cylinders. The disinfectant wipes that I use are a cylinder. So everybody make a cylinder, please. And what you do is you kind of make it into almost like a little tower, and then you can you can push it down. When I push it down, look what happens. It turns into a circular base. And then I can push down the other side. And now it's starting to look much more like a cylinder. And now I'm going to start to roll it. And I see Camilla doing such a beautiful job rolling hers because, and Alice, I can see your table, but I want to see you rolling that, rolling that. Good, Isabella, great job. And now push down again to make sure that the ends are nice circles. And now you should have something that looks like this. Now, from a top view, it actually looks like a rectangle, doesn't it? It actually looks like a rectangle. Yes, Allie? You'll have to unmute yourself.
I can't make a cylinder because I only have kinetic sand.
Oh, do not worry about that. Allie, do your best and maybe make a, just put it together as a ball. Kinetic sand is hard to deal with because it falls apart. I have kinetic sand too, Allie, and I love my kinetic sand. It's really cool. Maybe I'll show it to you later. Okay, Alice, you have a question.
I don't have Play-Doh.
Oh, okay, then you can just watch and just think about all the things that we're doing. As I said, you don't have to have it right now. You can get it during the week or something else. Do you know that somebody once did this out of tofu? Can you believe it? They did this project out of tofu. I knew someone who did the product with hummus. Hummus? What? Hummus? Now, you're not going to believe this, but somebody once did it with dirt. They went into their backyard and they literally got a bunch of dirt that went together nicely, and they did it with dirt. I even knew someone that did it with snow and ice. I'm telling you, it's amazing. So right now, I want everybody to measure with their ruler how long this is. Now mine, you would not believe it, mine is exactly 10 centimeters. Do you guys remember that a centimeter is 1/100th of a meter? So 10 of these centimeters. Remember, I also told you that a centimeter is about the width of a pen. So if I put my pen down, you can see that each of these is 1 centimeter wide. And watch what I'm going to do. I'm going to use my tool to make little marks for every centimeter. So do the best you can do at making little marks at every centimeter. And I'm going to make mine a little bit darker. You know what I do sometimes too, guys? I use my ruler as a knife because it really cuts nicely. And I really like to do that. And so I hope that you are splitting your cylinder or your kinetic sand into 10 equal pieces. Now, everybody, let's count them. Are you ready? Go. 1/10, 2/10. Come on, help me out here. I'm going to unmute everybody so they can all count together. Ready? Go. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10. Oh my God, it's a whole solar system. You are holding the entire solar system in your hand right now. I hope you don't drop it because we're in it. Okay, now I want you to make a cut. I want you to make a cut at the 6/10. So count over. 1, 2, 3, 4, 5, 6. Who can tell me what we have left if we cut off 6/10? What do we have left if this is 6/10?
4.
How many tenths do we have left, everybody? Say it.
4.
Oh my gosh. You should have 6/10 on this side and 4/10 on this side. Now, you wouldn't believe it, but I want you to all pick up the 6/10. and you are holding the largest planet in our solar system. Everybody make it into a sphere if you can. Make it into a sphere. And watch how I move my hands and I keep turning it. I turn it, I turn it, I turn it, I turn it. And it's not a really good sphere, but it's getting better. And then I could keep pushing it and pushing it. And you know what I'm gonna do? Because I love math and art, I'm gonna make a little J right on the top because I know that this is Jupiter. You don't have to make a J. I'm not even gonna make a little top to the J. I love the J from Jupiter. And Sabrina, you have a question, love. What's your question? You'll have to unmute yourself too.
I don't have a question, but I'm not ready yet.
Okay, well, you know what? If you're not ready, just put Jupiter aside. Just put Jupiter aside. Now, everybody, here's what I want you to do. Take Jupiter and put it right on top of where it says Jupiter on your picture. So put Jupiter right on top of that and put it aside. You will not be using Jupiter again. Okay, guys, you now have 4/10 remaining. How can anyone say, Mr. Kramer, how many fourths do we have here? Say it, guys. 1/4, 2/4, 3/4, and 4/4. I want you guys to please right now cut off one of the fourths and make sure you don't make it too small. Remember, it should be the same as the other fourths. So now I have 3/4 and 1/4, and that's what you should have. Now, I'm going to ask you to do something right now, and you're not going to believe it. You're going to pick up the 3/4, which is 3/10, 30% of the mass of the planets in our solar system. And I want you to make a sphere out of it.
White piece of paper?
Who can tell me what planet this is going to be? If you can, raise your hand if you can tell me. This is one of my favorite planets. Does anybody know which one that is? Say it on 3. 1, 2, 3, go.
Saturn!
Well, guess what? I want you to put it on Saturn, but it's not done. You're going to add to this 2 more times. 2 more times. Are you ready? Put it on Saturn. Go for it. Now, 10%, 1/10 of all the mass of the planets in the solar system. That's all we have left. That's all we have left. And here's what I want you to do. I want you guys to cut it in half. So I want you guys to cut this now in half. Now I'm going to take my knife and watch what I'm going to do. I'm going to make a mistake. Do you guys think that I did it at the halfway point?
No.
Say, no way, Mr. Kramer. There is no way that is 1/2. And guess what I can do? Just turn it over. Just turn it over and try it again. But you know what I'm going to do? I'm going to make a little bit of a better cylinder first. And do you know that I make mistakes doing my math all the time? And I don't care because I just fix it and do it again. All right. Are you guys ready? I made a little cylinder. And I'm going to cut this in half now. And maybe I should take my ruler and say, ooh, mine is 6 centimeters. What is the halfway point of 6 centimeters? Say it on 3. 1, 2, 3, go.
3.
All right, make a little cut right there and cut it all the way down the middle. Now, I want you to look, and whichever one looks a tiny bit bigger, put that one aside. They should be the same. Put that one aside and pick up the other one. Now, go get Saturn. You are going to add this to Saturn. But guess what Mr. Kramer does when I add this piece? Who knows what I'm going to do right now before I add this piece to Saturn? Does anybody have any ideas? Allie, what's your idea?
Make a cylinder.
Well, I am, but
Put an S on it.
wait, Tess, say what you're going to say, honey.
Put an S on it.
Ooh, I could do that. Charlotte, what do you have to say?
You're gonna make a snake.
I'm going to make a very, very long snake. Do you know why? Who can tell me why I'm making a very long snake? Victoria.
Rings.
Oh my gosh. Did she just say rings? Did she just say rings? Everybody watch this. I am going to make the rings of Saturn. Now, you don't have to do this. This is only for people that are crazy about Saturn like me. And I love Saturn, and I'm going to add the rings to it. Now, did you guys know that the rings of Saturn extend out bigger than Jupiter itself? So if you looked at the entire circle that was the outer ring, it's actually bigger than Jupiter. It's actually bigger than Jupiter. So it's even bigger than our Jupiter. Now, put Saturn aside. We're not done. We're going to add one more time. Put it aside. Now, everyone take the remaining Play-Doh and make a cylinder out of that. Make a really good cylinder, whatever you're working with, Model Magic, Play-Doh, or if you're doing it like Alice is doing it in her head right now. And Alice, you could actually make pictures. Why don't you make a picture of a cylinder and then you could split up that picture, okay? That's what I would do. Now, everyone, here's what I'm going to do with this right now. I want everybody to put their new cylinder against their ruler and measure it. So Alice, for you, I want you to draw a cylinder on your piece of paper and then measure that. Oh, guess what mine is, guys?
Mine is 8 centimeters.
Mine is 9 centimeters. Who said they had 8 centimeters?
I did.
Oh, Cam, that's awesome. So everybody listen to me right now. Who remembers how many millimeters is in 1 centimeter? Who remembers that?
100.
Who remembers that? How many millimeters in each centimeter? Remember, millimeters are really, really tiny.
10.
Oh, did you say 10? Camilla,
Yeah.
Camilla, 10?
I said
Is it
10 too.
Awesome.
I said 10 too.
Awesome. So everybody, if Mr. Kramer has 9 centimeters, who knows what 9 times 10 is? Who can say it on 3? 1, 2, 3, go.
9.
Not 9. 9 times 10.
90.
Oh, wait a minute. Everybody hold up their fingers right now. Everybody. 10. Come on. 20.
30.
40. 50. 60. 70. 80. 90. 9/10 is 90. So guess what? I need to split that up into 5 equal pieces. So here's what I want you guys to do. Take the number of centimeters that you have, and I want you to double it. So Cam, you had 8 centimeters. What's double 8?
80.
Nope. What is double 8?
Wait, double 8?
Yep.
That would be
So 8 plus 8. Remember,
let's see here.
8
8
plus 8
1, 2, 3,
equals,
4.
anyone know? You can say it.
Oh, 16.
It is 16. Now, Mr. Kramer's is 9 centimeters, so I'm going to go 9 plus 9.
That's 17.
Not 17, but 18. Now, guess what I'm going to do? I am going to make a little mark every 18 millimeters. So here I go. I'm going to go 1 centimeter, which is 10, and then another 8. I'm going to go 10 more, and then another 8. And that would bring me to, let's see, I have 18. And then I'll be at 36.
I'm doing it.
And then I'll be at 54. Oh my gosh. Guys, before you make any cuts, make sure that yours looks a little bit like mine. You should have 5/5. 1, 2, 3, 4, 5. If you made a mistake, turn it over and do it again. Don't worry. Brandon, you have a question. Go for it, buddy.
I'm actually telling you that mine is 29 centimeters.
Wait a minute. 29 centimeters is as long as this ruler. Are you sure yours is 29 centimeters long?
Uh-huh.
Why don't you hold it up? Why don't you hold it up?
Okay.
Hold it up into the picture where I can see it. Wow, that's a really long one. So buddy, what you want to do is you want to make a mark every 6 centimeters. About every 6 centimeters. Now, does everybody have 1/5, 1/5, 1/5, 1/5, and 1/5, which is 5/5? Does everybody have 5/5, which is a whole? All right, Camilla, do you have a question, love? You have your hand up.
Oh, I forgot to lower when I was going to ask.
All right, no problem. Now, everybody, no matter where you are right now, take your knife and cut off 1/5.
12.
And now take the remaining 4/5 and cut it in half. So what you should have right now is 1/5 and 2/5 and 2/5. How many fifths is 1/5 plus 2/5 plus 2/5?
24.
How many fifths, everybody?
Yes.
5/5. That's right. So now, guess what? Put
This is gonna be an
1/5
hour. This is
aside for
already
a
so
minute
long.
and pick up your 2/5.
It's already been so
And I
long.
want you guys to make a sphere out of each one. Make a sphere out of each one of the 2 of the larger pieces. Now, these 2 planets are referred to as sister planets because they're very, very similar in size. Who can tell me what these planets should represent? Tess, what do you have?
Mars and Earth.
Interesting. Mars and Earth. Now, Mars is actually a lot smaller than Earth, but it's the closest planet to Earth, which is very, very interesting. So not exactly Mars. Who has another idea about the sister planets? Gabby, what's your idea? And you'll have to unmute
Venus
yourself.
and Earth.
Oh, guess what, guys? Venus and Earth are also called sister planets. But guess what? Not these. These planets are massive. They are 40 times bigger than the planet Earth. Camilla, what do you have to add?
I just forgot what I was gonna say.
Okay, how about you, William?
I think one of them are Pluto.
Not these. These two planets. Are you ready? Now,
I
get
know.
ready for this. Wait, Doris, tell us.
I think I know. Uranus and Neptune.
Oh my God, she's right. Neptune
Uranus and Neptune.
and
That's what I was gonna
Uranus.
say.
Now listen to this, guys.
That's what I was gonna say.
Very few people can say the name of Uranus without laughing because it sounds like Uranus, but that's not the way it's pronounced. Uranus is the Latin, and in Latin, you pronounce that planet by Uranus. Everybody say
Uranus.
Uranus. Uranus, Uranus. Put it at Uranus and Neptune right now.
Yes.
Go.
Uranus
and Neptune.
Uranus.
Now, guys, guess what? The remaining piece, you're not going to believe this. You're not going to believe what we're going to do. This remaining piece makes up Mercury, Venus, Earth, Mars, Pluto, and the rest of Saturn. Remember I told you we would be adding to it one more time? Everybody make a cylinder out of this right now. Everybody make a cylinder out of our remaining piece.
Kim, where are the colors?
Colors? I don't know.
All right. Now, I want everybody right now to cut off 1/10.
I believe.
Now, I want to show you what 1/10 is. Mr. Kramer is going to make a little diagram where this is the 1/2 mark, and each of these represents a 10th. So I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I am going to cut off 1/10 right now. Everybody do it with me. Come on, cut off 1/10 only.
One?
And there's my 1/10.
What the heck? Suck that to it.
Did everybody do it now? Now, here's what I want you to do.
Yeah.
I want you to pick up the 9/10. Everybody pick up the 9/10, and you guessed it, we have to add it to Saturn. So if you mush it into Saturn, Saturn is now completed. You will not be touching Saturn again. Put Saturn back next to Jupiter, and between Jupiter and Uranus, and guess what, guys? The remaining piece makes up Pluto, Mars, Earth, Venus, and Mercury. Make a little cylinder out of this, guys.
I can't.
Now remember, this is not the tricky part. The tricky part is coming soon. Can you believe it? Say, Mr. Kramer, how can this get any more tricky? Okay, are you guys ready? I want you guys right now to cut this piece in half. Try your best to cut it in half and mark it first before you cut it. I kind of like my mark. Can anyone tell me, do they think Mr. Kramer did a good job of cutting that in half?
Yeah.
Pretty good, pretty good. Now, everyone, please pick up one of those halves. But I want you to be really careful with this one. Why would you think I would want you to be really careful with this one?
You might drop it.
If I drop this one, that's not going to be good for us, because this is your planet. I want you guys to take between your thumb and forefinger, and I want you to make a sphere out of planet Earth. And there's a song, I'm not going to sing it for you because I don't sing very well, but there's a song from the 1960s that was, I got the whole world in my hand. I got the whole, can you guys sing? World in my hand. I got the whole world in my hand. I got the whole world in my thumb and forefinger. Now, take Earth and be very careful. Don't drop it. Don't drop it. Oops, oops, I almost dropped you guys. Put it on Earth on your picture. Now, you wouldn't believe it. Victoria, you have a question. Oh, Victoria, you are muted. Go ahead, Victoria. Victoria, you have a question. You want to speak, honey? You're not muted anymore, but your computer sound is turned off.
Now,
Now,
can you hear me?
I can hear you beautifully.
I think you sing pretty good.
Oh,
me
great.
too.
Now, guys, are you ready? That's very nice of you. That's very, very nice of
Me
you.
too.
But I won't be winning American Idol anytime soon. Now, I want you guys to cut off 1/10 of that piece. You have now 9/10 and 1/10. This is 1/10. This is 9/10. And I want you to pick up the 9/10. And this, I don't remember who told me this. It may have been Allie, it may have been Tess, I'm not sure. But this is our sister planet. This is Venus. And we never, ever want to go here. And the reason is that Venus is very, very hot. On the surface of Venus, you could melt lead. Lead is very, very hard. You could not melt it on Earth, but you could melt lead on the surface of Venus. So we're never going to go there. Put this right next to Earth on your picture. It is slightly smaller than Earth. It is 1/10 smaller, or 10% smaller than Earth. It is 90% of the volume of planet Earth. Now, everyone, the remaining piece, this is where it gets really tricky. I want everybody to make a cylinder out of this. I don't even know if I can do it. I'm gonna try. I made like a little snake. I think Charlotte was the one who gave me the idea of calling it a snake. But yeah, if you make a little snake out of it and you try to make it uniform, I want you guys to cut off 1/10. So cut off 1/10 of that piece. And guys, I do not expect you to be able to do this. This is really, really difficult. And guess what that 9/10 is? Who can tell me what planet that is, guys? Go for it,
Pluto.
Jeremy. Jeremy, you'll have to unmute yourself.
Mercury.
Oh, it is not Mercury. This is where, Victoria, what do you think it is?
We haven't done Mars yet.
Pluto.
Oh, not Pluto. Gabby, what do you think?
Jupiter. Mars.
Oh my gosh, it is Mars. Guys, this is the planet where Elon Musk, the man who owns SpaceX, who just launched the rocket on Saturday, this is where he wants us to live. He wants us to live on Mars, which is 1/10 of the size of Venus. Everybody put that on Mars right now.
Play-Doh.
It's very, very small. Now,
Kramer,
yes.
I'm using very unsafe knives. They're the most dangerous knife we have in the
Would-
whole kitchen.
Brandon, would you do me a favor and put those knives away, please?
But
Because,
these are the only cutting things we have.
yeah, I would rather you use your ruler, Brandon. You're only allowed to use a plastic knife. Even Mr. Kramer uses a plastic knife. Okay? So even Mr. Kramer uses a plastic knife. Now, guys, if you can find your remaining Play-Doh, cut off 1/10 of it. Now, this is the part that I usually have a hard time with. And guys, this is my 9/10, and this is gonna be Mercury, everybody. Everybody put that piece on Mercury. And guess what, guys? The remaining little specks,
Lucky, I found it.
this
the tiniest piece ever.
is Pluto.
Can't find my phone.
Now, guys, Allie, you have a question, sweetie?
That's like the tiniest thing ever. Let's stand it. We have so far.
Say again, Allie. Wait, Allie, I'm gonna mute everybody and then I'm gonna unmute you. Hold on. Allie, go for it.
I want to go over which planet we have.
Okay, so let's do that right now. Mr. Kramer's gonna take Pluto and put it right by Pluto. And let's see if I can show you what this should look like. I'm gonna move mine over. And some of my planets are rolling around, like Earth just rolled a little bit. This is what I have right now. And guys, is there something missing from our solar system that we created? Who can raise their hand? Who can raise their hand and tell me what's missing? And I have a couple of people that are looking to raise their hands. Jeremy, go for it, buddy. And Raymond, go for it.
The moon.
Go ahead, Jeremy. Raymond?
The sun.
Oh my God, guys, where's the sun? Well, guess what? If the Play-Doh that you just made for Jupiter, Saturn, Uranus, Neptune, Earth, Venus, Mars, Mercury, and the tiniest planet Pluto, if these were the size of those planets, would you like to see what the sun would look like? Are you ready? Don't go away. I'm coming right back. And everyone, guess what? A 75-centimeter exercise ball is equivalent to the sun as compared with our Jupiter, guys. Look at the size of the sun as compared with Jupiter. Have you ever seen anything like it? Now, if you have an exercise ball in your house, when you make another model, and I hope you guys make lots and lots of models of the solar system, put it up against your exercise ball. Now, I want to tell you a little story about these. Are you guys ready? So if you guys go to page 4 in your packet, I want to tell you guys that if you wanted to make the sun out of Play-Doh, do you know how many pieces you would need? Now, I want you guys to listen to this. Are you ready? I'm going to unmute everybody. We started out with a piece of Play-Doh that was about this big. This is 1 pound of Play-Doh. Guess how many pounds I would need to make the sun? I would need 650 pounds of Play-Doh. It would fill your whole room. It would take up all your room in your bedroom. You wouldn't be able to sleep. So are you happy that I didn't have you make the sun? Are you happy? Because that means you can sleep. Okay?
Yes.
So,
Yes.
can I?
No,
The sun is a little bit hot. Can I put it down? It's a little bit hot. Can I put it down? Okay, good.
Not real though.
Well, it's real to me because we're making a model, a scale model of that planet. Now, I want you guys to go to page 4. Page 4 in your packet is so exciting. I had a lot of fun making it for you. And I'm going to actually share a different screen now. And I'm going to share my desktop. I hope everybody can see it. And if you go to page 4, it tells you all about the relative sizes of the planet. So for instance, if Earth, and I want everybody to just pick up their little Earth for just a second. Pick up Earth and pick up Neptune. Neptune is 40 times bigger in mass and volume than Earth. Pick up Saturn.
Mom, I don't have a Neptune.
Saturn,
Oh, never mind, I do.
718 times bigger. Guys, you could put 718 Earths inside of Saturn. But then, of course, Saturn would get bigger. But no, not really, because you wouldn't actually put Earth into Saturn. Now, guys, how many Earths could you put inside Jupiter? Does anybody know? How many Earths can you put inside Jupiter?
1,200.
1,200 Earths. Now, don't try this. Don't try to make 1,200 of these Earths because it'll take you a long, long time. Now, how many, if anybody still has their Pluto, by the way, here's my Pluto. My Pluto is now stuck to the end of my finger. Compare Pluto to Jupiter. You could put 1,200,000 Plutos into Jupiter. But it gets better. You can put 300 million Plutos in the sun. Now, does the sun seem very large to you? Yes or no?
Yes.
Yeah.
It does? Well, guess what? Our sun is known as a dwarf sun. It is considered one of the smallest suns in our galaxy. So in the Milky Way, we are one of the smallest suns, and yet our sun is huge.
Our sun is a dwarf sun.
It is a dwarf sun. So do you know that the sun is 1,300,000 times bigger than Earth? It is unbelievable. Now, please put down Earth and Jupiter, and let's take a look at something else. Mr. Kramer was wondering what would happen if I took a piece of paper and I split it up into tiny, tiny millimeter squares. And look what I did, guys. Each one of the squares, and by the way, this is on your page 5. If you take this page, you will see that I split it up into Jupiter, Saturn, Uranus, Neptune, and then look at this little piece, guys. That little piece makes up 1/1000th of the volume of all the planets. And that's Mercury, Venus, Earth, Mars, and Pluto all together. Earth is half of that. Now, you could actually do this because I gave you a blank page on page 4. So you could have some fun with that. Now, I want to end class with a question. Who can tell me, go to page 8 in your packet right now. It's got a bunch of pictures of solar systems. So go to page 8, please. And what I want you to do is put your finger where you think it's a good picture of the solar system, a picture that makes sense. For instance, you know very, very well that this picture right here is a bad picture. It's showing everything. Well, those are actually moons. This one right here, not really sure about, let's see. Oh my God, this one right here, this is not a very good one either. Which do you think is a really good picture? Raise your hand. Allie, where do you think it is? Unmute yourself.
I thought some planets were gases.
They are. Jupiter is gas, okay? Jupiter is definitely made of gas. That is very, very true. William, can you tell me which picture you think is a good picture of the solar system? Go for it, Will.
This one.
Can you describe, is it high or low in the picture?
Third row, second column.
So you think this one right here? It's a good one, but not even close because the sun is too small. Very good, William. And Doris, what do you think?
The fourth column, fourth picture.
This
not that one.
guy's,
Not that one. I mean,
yeah.
like,
This one here is good, but this one here is the best. And I gave you that picture, guys, on the last page. This is the picture that shows the actual relative size of the planets. Now, guys, I'm so excited that we got to do this together. Let's go from Pluto and count down all the way to the sun. Are you ready? Here we go. Pluto, Neptune, Uranus, Saturn, Jupiter, Mars, Earth, Venus, Mercury, and the sun. 0, 2, 4, 6, 8. Who do we appreciate? Mathlete. Go Mathlete. I'll see you in 167 hours. Bye, guys.
Bye.
Have fun exploring the universe.